All right, section 9.3, we are talking about multiplying radicals or multiplying terms together that have radicals. The way that we multiply these, so if we just have two whole numbers, I would have, if I just had 3 times 4, we multiply them, we get 12. Now we're going to say what happens when we have whole numbers, or we have radicals, or we have a whole number with a radical tied to it. So in this case, we have 3 square roots of 6 times 4 square roots of 5. How we multiply these is we're going to take the two coefficients, so in this case, 3 times 4, what I just did, we're going to multiply those together. But then we are also going to take our square root, and any numbers inside the square roots of the terms getting multiplied, they get multiplied underneath the square root. So I'm just taking, my two whole numbers, so 4 and 3. Those will get multiplied, and that will give me my new coefficient number. And then I'll take my square root, 6 and 5. Those get multiplied, but since they're both underneath a radical, or a square root symbol, they get multiplied underneath of that. So in this case, my answer, I would have 3 times 4, which is 12. And then underneath my square root, 6 times 5 is 30. So 12 square roots of 30 would be my final answer. If you can simplify the radical, we would do that. But in this case, we cannot simplify the square root of 30, so we just leave it, and that is our final answer. So with that, let's go ahead and look at example A. So in this example, it's a little different. I have a coefficient in front of my square root of 6. It's negative 3. But I don't have a coefficient in front of the square root of 8. Similar to, when we have terms that don't have an explicit exponent or different things like that, we can assume the coefficient here is 1. So if that's the case, the answer for this problem would be negative 3, and then you can write times 1 if you want to. You really don't need to. And then underneath the square root, we have 6 times 8. So simplifying this, we get negative 3 square root of 48. You can use your calculator. And then we can simplify the square root of 48. So if we do some work here, we'll realize that 48 is actually 4 times, it's not 4, it is 3 times 16. And 16 is a perfect square. The square root of 16 is 4, so I need to remember these are both still square roots. So the square root of 16 is 4. So my final answer, actually, I can take 4 out of that square root, and now I'm just left with this 3 here. And then if I want to simplify this, I have negative 3 times 4, which is negative 12, and then I still have my square root of 3. All right, moving on to problem B. We have negative 3 square roots of 12 times 4 square roots of 3. So once again, the coefficients, I have negative 3 times 4. We're using those guys a lot. And then underneath the square root, I have 12 times 3. So if we simplify this, I get negative 12 times the square root of 36. 36, we don't even need to break it down. That is a perfect square. So we can pull out a 6. The square root of 36 is positive 6. So our final answer, we take negative 12 times 6. You should get negative 72. Moving on to problem C. For this problem, we don't have any coefficients on either term, so we can just assume they're both 1 if you want to. But really what we're focusing on now is just multiplying the stuff underneath the square roots. So I have 5 times 2, because those are the numbers underneath the radical, but then they both have variables as well, so we need to multiply those. So our multiplication laws with variables still stand. So I have b squared times b squared. And so you can think about this problem without the square roots if you want to. What's 5b squared times 2b squared? You multiply the coefficients, and then you multiply the variables by adding their exponents together. since they're the same base of variable. But we just have to do this all underneath of a square root. So simplifying this, 5 times 2 gets us 10. B squared times b squared gets us b to the 4th. Now we need to ask, can we simplify anything in this? The answer is yes. The square root of 10 cannot be simplified. That won't break down for us. But the square root of b to the power of 4 does. So we need to ask ourselves, what times what gives us b to the 4th? Well, in this case, we actually saw it in the previous step. B squared times b squared, that actually gets us b to the 4th. So we can pull out b squared. So in this case, our final answer would be b squared times the square root of 10. All right, go ahead and pause the video on problem D. I want you to try this one. Once you think you have it, click unpause and see if your answer matches up. All right, after simplifying, I got 30k squared times the square root of k. So if you got a different answer, go ahead and check your work alongside that and see if you made a mistake somewhere. All right, problem E. Now we have a binomial, so the square root of 3 plus 4 in parentheses, and then multiplying by this parenthesis, we have the square root of 5. So we need to distribute our square root of 5, and then from there, we're going to see some multiplying with square roots. So I have the square root of 5 times the square root of 3. That is going to be the square root of 5 times 3. And then plus the square root of 5 times 4, that's just going to be 4 square roots of 5. So simplifying, 5 times 3 is 15. So I have the square root of 15, and then I still have plus 4 square roots of 5. And I do not believe that can be simplified anymore, so we are just going to leave that as our final answer. So same rules that we've been following, we're distributing, and then we just have to simplify our square roots. Problem F, this one's a little more in depth. So we're still distributing. I have 3 square roots of 3, and I'm distributing that to the 4 and the minus 5 square roots of 5. So 3 square roots of 3 times 4, I'll multiply my coefficients. So 3 times 4 times the square root of 3 minus 3 square roots of 3 times 5 square roots of 5. So I have 3 times 5. Let's put these in parentheses just to know what's what. And then I multiply what's underneath the square root. So that's also 3 times 5. So this 3 times this 5 is here. But then the square root of 3 times the square root of 5, that's what's underneath the square root here. So now we can simplify this. So 3 times 4 gets me 12, and I still have the square root of 3. Minus 3 times 5 gets me 15, and then my square root is going to be 3 times 5, which is 15. And those square roots cannot be simplified anymore, and we do not have any like terms, so they cannot be combined. All right. There are 2 remaining problems. I want you to try G and H and then unpause to see what you get. So for both of these, you will be distributing a term with the square root into the parentheses. After you multiply, check and see if you have any like terms. But if you do not, then just make sure you indicate what your answer is.